You might have seen an attack that was pulled off using an EC2 instance or EC2 instances previously, where someone managed to make a request through the instance to the AWS metadata service. And then as a result of that, they managed to grab some credentials. And Amazon's put in a load of mitigations to this issue, and they've also improved the metadata service and given you some additional options. So we've got an EC2 instance here, which is a nice fresh ARM instance, just a little one, a micro one. And if I go to instance settings here, you can see that we've got some metadata options. So you can require IMDS-v2, which is the mitigation to that issue I was talking about earlier for making requests through an instance to the metadata service. You can even turn the metadata service off if you wanted to. And there's another setting that I really like to enable called allow tags in instance metadata. And you can see that that's not enabled currently. And what this does is it gives you a URL you can call which fetches the tags that your instance is assigned to. And I find that really, really handy if you're trying to make the behavior of the instance deterministic based on the tags it has set. So we want to enable that with our EC2 instance that we have in CDK. So here's our instance. We're using a nice abstraction for the family and size of the instance type. We've got an AMI lookup using the latest and greatest Amazon Linux 2023, and I've asked it to cache the value in context so that it doesn't churn through EC2 instances when the AMI is updated. And of course, we have to choose an ARM image for an ARM machine. We've also got a VPC lookup, which you can find more about in the lesson on referencing existing infrastructure. So that's our instance. We've made it. We've got a tag. And we want to set the metadata options, but unfortunately that's not yet available to our instance construct. So I have a bit of a scroll down here, then I wouldn't be able to find anything that is relevant for that. Wouldn't be able to find the right settings. So we have require IMDS-v2, for example, but we don't have the rest of the settings that I need, and there are quite a few that you can change. And if you went and looked at the CloudFormation resource, you would see that they are also not supported in that resource. And so we have to make a custom resource. Let's go and have a look at the AWS API call behind this, which is modify instance metadata options. You can see it there on the left-hand side. And there's an instance metadata tags value. And we would like to set it to be enabled. That's the goal of our little exercise here. The easiest way to do that in a lot of cases is using the AWS Custom Resource construct. And this is a really flexible construct that takes in a service name and an action, and then you give it some parameters and you can put in whatever custom values you like, and you can tell it how to derive some IAM credentials, and when you do that it will create a Lambda function and a custom resource. The custom resource will call the Lambda function, call the AWS API, and then you achieve what you're trying to do. You get your aim. And that can be a bit of a lookup like this, where they're using SSM get parameter, I think just as a toy example. Or it could be something like we're trying to do, where we are making a change to a resource. So how do we do this? And how do we know what the right values for service are and the right values for action? Well, the AWS Custom Resource construct is based on the version 2 node SDK for AWS. So you can see here we have the documentation for version 2, and I popped into the EC2 service, and the service value that we can see in our AWS custom resource is this value here after AWS dot. It's this one in capitals rather than say EC2 in lowercase. Okay, let's set our custom resource. So we're going to find the SDK method we want to call, and let's look for metadata options. Here we go, modify instance metadata options, and then we get all the parameters here that tell us how it's going to work. So we can go into our CDK project, we can make a new AWS custom resource, we can attach it to the current scope and call it maybe, I don't know, test instance set options, and then we have to specify some parameters. We're not going to change the value of this ever, we're only just going to set it to enabled and call it done. So I'm going to set up the onCreate parameter. Bear in mind you have three options here. You have onCreate, onUpdate, and onDelete. And if you want, you can just do onCreate and onDelete, and when an update is provided, it will just run your delete and then you create. So you don't have to specify all three if you don't want to. We only need onCreate for our use case. We're not interested in turning this off again if the custom resource was removed. That's not really applicable for our use case. Then we have to specify the service, which is going to be EC2. We have to specify the action, and we can copy that from the documentation page here using the same casing that the Node version 2 SDK uses. And then we need to think about the other parameters and bits and pieces that tie this together. So we need the data going into this API call, and again we're using the casing from the Node SDK. So we're going to have an instance ID, and that's going to be test instance dot instance ID. And then we need the parameter to enable the tags, which is this one, and it will be the string value of enabled. So that's that bit sorted. We also want to add in a physical resource ID. Now, you might not be really familiar with CloudFormation custom resources, and that's absolutely fine. The general concept is that you can either receive a message, say on an SNS topic, or you can call a Lambda function, and then that Lambda function or something on the other end of that topic does something that, that configures some kind of resource where you can't do that natively in CloudFormation. And obviously we have the logical ID here, which is going to get translated into a slightly different, but mostly similar logical ID for CloudFormation. But the resource needs to get a physical ID. And you think, well, what would we put for this resource here? You know, this is an instance metadata modification. What ID does this have? And you might be tempted to use, say, the instance ID, or what I will often do is set it to a constant value using physical resource ID.of, and then I'll set the version of this configuration. So this is the first version of me running this command here and changing these settings. And then if we change these parameters again and I need it to be reapplied, I'll change this to version 2 so that we get an update. All right, now that we've done that, we have to specify how it's going to get an IAM policy. And you can see for our AWS Custom Resource policy, we have two options, one from SDK calls and one from statements. From statements lets you manually build up a policy, which can be useful if the from SDK calls bit fails. But from SDK calls tries to be clever, and it tries to find the right IAM actions for the action that you're using here and the service that you're using here. And it's not perfect, but most of the time it's perfectly sufficient. That's what we need. So let's do from SDK calls, and then we have to specify an array of resources. And we're going to do some quite fine-grained authentication here, and we're going to put in the ARN of the EC2 instance. So we'll do ARN AWS EC2, then the region using the aws.region, which is going to get translated into a token for CloudFormation, and then resolved when it deploys. And then we want an instance, which is going to be at a particular instance ID. Okay, so we found the service with the Node.js SDK version 2. We got the right class name, we got the right action name, we put in the parameters in the same casing that's in the Node docs. We talked about a physical resource ID to keep it consistent if we're not changing any settings, and we've gone for a fine-grained permission here. So let's give it a run and see what happens. All right, and let's go and view our instance in the console. We'll give it a refresh and look at the settings for allow tags and instance metadata, and that is now checked as enabled. So we've done that, and that worked really well. And let's talk about some caveats of this approach. One of the caveats is that the AWS Custom Resource tries to reuse the same Lambda function for multiple invocations. So if I pop and look for this in the documentation, and we go and have a look at the source code, and then we find where the Lambda function is created, you can see it uses the singleton function class. And that can mean we avoid a bit of duplication. You know, we keep the Lambda there, keep it available. But the downside of that, or the caveat, is that it's going to share the same role. You can have multiple invocations of your AWS Custom Resource, and they will have almost like a race condition, because it's going to be whichever is the first one to be set up. And then they all get that role. Now, if you're using this method here, where we're having a policy, then that's fine, that's absolutely great. They should all get added to the role as separate policies. So let's go and have a look at those in the console. Let's have a look at IAM. And we'll see how easy it is to find the role. Here we go. And then you can see we've got a policy here, test instance set options custom resource policy, and that's got our permission to modify the EC2 instance metadata options. So you could imagine that if we had multiple instances of AWS Custom Resource in the same scope, and they all shared the role, they all got a policy added, then we would be happy, that would work fine. And you could get up to a limit if you had too many policies or lots of instances of it, but you'd have to have quite a few of them in there to have that effect. The challenge comes if you decide that instead of specifying the policy here, you're going to specify a role instead. And if you do that, then you're racing between the other instances, which may use a different configuration for IAM. Maybe they use a policy and a role generated by the construct, and your one where you're specifying your own role. If you're going through some challenges with the AWS Custom Resource construct, I highly recommend you using the no rollback option. And then you can inspect things in place and see what's happened. If you really have problems, you can create a custom version of this which has your own Lambda function and your own configuration and all the rest of it, and try and avoid that challenge. But you have to see if you run into it or not. I think the other caveat is that the retry behavior of the AWS SDK cannot be appropriate sometimes. For example, I recently wrote a version of this for setting tags on CloudWatch alarms, and you can call that API roughly once a second. But what was happening is it was trying to tag many CloudWatch alarms at once. They were going into a retry process, and there was an exponential backoff with jitter, so they were waiting a really, really long time before trying again, and then eventually failing. So in some cases, you might have to say, okay, all right, I'm just going to have to write a custom Lambda for this, do my own custom resource, because I need to control that retry behavior. I think the third situation or caveat I would talk about is that sometimes you only want to create the thing, whatever you're doing, if it hasn't already been set up. So you might want a custom resource that tries to create something, and if it fails because it already exists, it says, oh, do you know what? We're quite happy with that. That's okay. I'm just going to configure it. An example of that is the log group, log retention construct that's used by the Lambda function construct. The log retention construct will make the log group if required, otherwise it will just change the log retention. And I think that's a really nice example of when a custom resource is used to handle that upsert case, if you like, where we only create it if required.